How's it going? My name is Ryan McNeal. This is my ENME 489Y facial detection homework submission. I changed the code a little bit from what was gone over in lecture. I found it really time consuming to have to load the video and iterate through and change the video itself. So basically, I just rigged it up so that it works with my webcam instead of using a video. The way I changed that is you just take out the argument for video, and instead of getting a frame or this capture object from the video, you just use 0, which is the input from your webcam. You also don't have to iterate through to get the number of frames anymore because it's just a consistent loop that is always running. So going through the actual pipeline for the facial detection, you load in the prototext in the model that we got off Elms, and you start the loop. You take every frame from the incoming video, and this is the actual algorithm itself. Create a blob with the resized image, then you set the net input to be that blob, and then you get your detections from the net. The detections, you iterate through that object, which is the number of detections found, and you get the confidence of each detection. The confidence is just how sure the algorithm was that it found a face, and you compare that to the confidence that is passed in. For all of these, I use 50%, which is default, but you can change it if necessary. You then get the bound box, which the detection algorithm found as the area where the face was found, and you set your start XY and XY as those points. So commenting or uncommenting this and this, you can see the algorithm working. So you can see right here is the actual confidence. It does a really good job. It seems pretty sure that that's my face. And it does a really great job adjusting as I'm moving and tracking. Yeah, you see it. No, yeah, it does a really good job. So the next thing is just blacking out the face. Taking out that and that. So the way we do this is we take that area that is from the start and end Y, start and end X, and you just fill it in black. And that can be seen like this. Again, it does a really good job of blacking it out. It adjusts the height and width as I turn my face and different angles and such. If I move it really fast, it kind of stutters as it has a really hard time dealing with that. But again, slow, it does a really, really great job. So then let me pause this real quick. And here is the blurring algorithm. So one difference is this, as you can see, it gets really laggy as I'm moving around compared to the last videos. Like it doesn't do a good job of making it very smooth. The reason that is this section of code right here. Having 2 for loops in a code like this that is running actively is really slow and choppy. But the way it works is you have this area that's the same area that we use for the bound box and for the black square. And you define that as your area, and then you blur it using a kernel size 50. And you can change this to anything you want, and it will become less blurry the smaller it is. And then you iterate through, and you set every frame of the image to that blurred picture that we created. So this is a little less blurry. Yeah, you can see the line and stuff with the actual bound box into the black screen. Yeah, and that is really it. So you can see this is just the base program again. Yeah, that should be it. Thank you so much. This is the last homework. So thanks for a really great class. Really enjoyed it with, having to deal with everything. So thanks for everything. I learned a lot and really appreciate it. So thank you so much. Hope everyone continues to stay safe, and hopefully we'll see you guys next semester on campus. So thank you so much.